regardless of its application, either mechanical or electrical, is defined as the rate of transfer of energy, or how quickly energy is transferred. When I rev this bike, that's my favorite part. When I rev this bike, I'm asking the engine to transfer its energy more quickly. Now the result of that faster transfer of energy is the bike leaping forward, or really accelerating. Well, my timekeeper said I accomplished this task in 6.47 seconds. So 6.47. And I hope you got something close to that, and if you didn't, or not exactly, that's okay. We're just going to follow through with the train of thought anyways. Well, we have units in pounds, centimeters, and seconds. Well, our definition of work was, power was in terms of joules and seconds. So we need to convert our pounds to newtons and our centimeters to meters. So in order to get newtons, we have to take 5 pounds, and the conversion is 1 pound is equal to 4.45 newtons. So pounds go away, and we end up with, do a little bit of arithmetic here. So we have 5 pounds times 4.45 newtons is 22.25 newtons. So we'll put that right up here. 22.25 newtons. Now 119 centimeters is 1.19 meters. And now we're ready to calculate work. Well, work for the chin-up, or for the wrist roller, so these are the wrist rollers, and work is defined as the force, or the component of force, along the direction of displacement. Well, as I was rolling this up, my force, the force in the string, was directed up, the same direction as the displacement. So the angle between those two vectors is 0, cosine of 0 is 1, and so we end up with F times delta D. Well, we can see that our force from our table is 22.25 newtons times the displacement of 1.19 meters, and we end up doing here 26.48 joules of work in lifting this object up. So 26.48 joules of work. Now power is determined, because I know how much work I've done, my average power is the rate at which I did that work. Well, I did 26.48 joules of work, and I accomplished this task in 6.47 seconds. So 6.47 seconds. So my average power is 4.09. 4.09 watts. So 4.09 watts. Now, in order to convert this value to horsepower, we have to take 4.09 watts and run it through the conversion of 746 watts to 1 horsepower. So divide that number by 746, and you get 0.0055 horsepower. 0.0055 horsepower. All right, well, I suppose you could call it 5.5 milli horsepower if it does anything for you. But this right here is an expression of how much power I was having to exert to lift this 5-pound mass up 119 centimeters in 6.47 seconds. So we've taken our force elements and we've taken some physical aspects and we've ultimately determined power. Well, let's do it one more time for a chin-up.